Hello, I'm an old guy and I do maths, and today we're going to have a look at linear simultaneous equations, and we're going to look at solving them by elimination. This is probably the second most common method of working with these. If possible, and if it's relatively straightforward, you should always try substitution. There's a separate video on that on my channel. Anyway, let's get to work. So we have two equations, x plus y equals 5 and 2x plus y equals 7. And what we're going to do is we're going to try and eliminate one of the variables. And to do this, we just need to set these up slightly differently. We'll put 2x plus y equals 7 at the top, and from that we will subtract x plus y equals 5. And the effect of doing that is that we eliminate the y's, so y minus y is nothing, and we get down to 1x, which is very handy, and 7 minus 5 gives us 2. So this is a very simple operation to discover that x is equal to 2. Now, in order to get the y value, all we do is substitute in the value of x, which is 2, and solve for y. So what we do is just quite simply ask 2 plus what equals 5, and the answer is 3. So x is 2, y equals 3. If we were to draw these two lines on a single graph, they would intersect at the point 2, 3 on that graph. Now, I've asked myself a question here. Could substitution have worked? The short answer is yes, it could have, and it would be a fairly straightforward operation. So what I would do if I were going to substitute in, I would take 2x plus y equals 7, and I would substitute in a value here for y in terms of x, and y is equal to 5 minus x, which we can get from this just by rearranging this. So y equals 5 minus x. So we could say that 2x plus 5 minus x, which is y, equals 7. So 2x minus x is x plus 5 equals 7. And as we, let me just do that again. 2x plus 5 minus x equals 7. We can get rid of one of the x's and we're down to x plus 5 equals 7. So x is going to equal 2. And as you can see from up here, x does indeed equal 2. So this could have been done using substitution and would probably have been maybe a tiny bit faster and a tiny bit easier to do so, but this is a demonstration of elimination. Okay, let's look at something a little more awkward. So, here's something a little more awkward. 2x plus y equals 10, and what I've done here is I've multiplied this by 2 immediately. Okay, why have I done that? Because looking at my second equation, which is 3x minus 2y equals 8, I see that I've got negative 2y here. So if I multiply through by 2, what I get is 4x plus 2y equals 20. And I can add this to this And what I get for my trouble is 7x equals 28, and therefore x equals 4. Now let me just go through that again quickly. I saw that there was an expression here, negative 2y. So if I could make this positive 2y and add these, I would get rid of the y's, and that's essentially what I did. I multiplied through by 2, got 4x plus 2y equals 20, added. And it's always a choice whether you add or subtract. You take a look at what you're dealing with. In order to get rid of the y's, I add here, and I get 7x equals 28, x equals 4. Sub that in to one of the equations, and I chose 2x plus y equals 10. So if x equals 4, that is 2 times 4 plus y equals 10. 2 4s are 8. 8 plus y equals 10. Y equals 2. And then I put it to the test. I popped x and y into the second equation, which is this one here, 3x minus 2y equals 8. And sure enough, I got 8. 3 times 4, which is the x, minus 2 times 2, which is the y, equals 8. 12 minus 4 equals 8. That is my test, and that is how it is done. Thanks very much for watching. I hope this was at least relatively straightforward, and that these things are a little less threatening from now on. See you next time. Bye.